Okay, sixth graders. So everybody has been assigned to answer and read questions. Let me put those up here: 214, 215, 216, and 217. Um, we sort of were spending a lot of time on makeup work, so I am going to show the kids that were students that are on remote and those of you that were absent what we highlighted in this section. And I'm also going to give you your notes via a Google slide presentation. And I suggest that you use these before you answer the review sheet. Okay, so when we started, you guys read about describing motion, and we read about the Polish astronomer Nicholas Copernicus. He's considered the father of astronomy. He was the very first guy that said, you know what, I don't think Earth is in the middle. I think we're going around the sun. And the question asks you, why would most people think that the opposite was true, that the sun was revolving around us? And we came up in class that they saw the sun rise in the east and set in the west, but they never were off Earth. So from their standpoint, it definitely looks like the sun is traveling around the Earth. As always, you want to highlight bold-faced words. Motion is if its position changes relative to another object. Now I'm going to point to this word relative. And I guess in sixth grade thoughts, that would mean like compared to something. And an example about why do they need to change that is if we took a look at these two pictures and I asked you who was moving. This one was taken after this one. That's what this information gives me. And it wanted to know, was he moving this way, or is the red car in the back moving that way? And we need to compare. We need it to be relative to something. So in class, we chose the flagpole. This person's book was from last year, and they actually drew a line here. So here's the flagpole, and as you can see, the red car here, it's on the hood, and then down here, you can see it over the trunk, whereas the distance to the boy in the car has kind of remained the same. Now, we had students who were very perceptive, and they realized that the name of the school, we could see some more letters behind his head here appearing, so maybe he is just starting to move. And the only way we know that is by comparing him to the letters and comparing the red car to the flagpole. So we could say the red car relative to the flagpole has moved. The boy in the blue shirt relative to the flagpole hasn't. So as I said before, you want to highlight what is a reference point and that an object in motion changes relative to a reference point. So down here, we kind of answered that then. Did the car that the boy was in move, or did the car in the background move? And we thought the red car moved past the pole, and that would be explaining our answer. What objects in this photo make really good reference points? This person wrote tree, pole, and I added the school building. On the next page, it talks about relative motion and using reference points. If you sit right now perfectly still, that we might say some parts of us are moving, our blood is pumping through our circulatory system, our lungs are moving, maybe we're blinking, but if you compared yourself to the chair wouldn't really think that you were moving. However, you're actually rotating and revolving because you're on something that's moving. So it all depends on what you compare yourself to or what relative motion is. So this one says, let's look at this. One tree in your yard is stationary if you compare it to the earth. Go outside right now and look at a tree in your neighborhood. Then go back out in an hour, that tree is going to be in the exact same position. But we do know, because of, hopefully, if you covered a little bit of astronomy in fifth grade, you know that that tree is actually currently revolving around the sun. So it is indeed in motion, but just what you compare it to. So if you see people on a cool festival ride, hopefully this will come back after COVID goes away, and it asks you, are they moving relative to each other? She's not moving away from him. He's really not moving away from her because the distance between them really hasn't changed. But when you compare them to the ground, yes, that distance sort of has changed. And that's sort of what I wrote there. How is your choice of a reference point important when describing the motion of people? Let's think about two people on a train that if, well, let's put them in a train car or maybe just in a car. So this is a train car. And this person is looking at this person and they're trying to see who's going to blink first. As they look at each other, here's that train and it is moving this way. They compared each other, they'd be like, we're not moving, but this person on the street was obviously watching them move. So he can tell that they were here and then they were here. But if they looked outside and said, well, he was right here and now he's way off in the distance. So you need to be able to show a position change. And then on the last page, when we go to measure distance, it's actually, and you might want to write this down, we are showing the length. Length is, or distance is measured in length, and the SI, System International unit for the length, is the meter. Now, if you read this, I'm going to highlight some information that's going to help you on that review sheet. The prefix milli actually means 1,000, so there are 1,000 millimeters in a meter. And down here, there are 1,000 meters in a kilometer. If I didn't do that, I wanted to show you that if you were to come over here and answer the questions that I asked you to do, it indeed asks you the information that I highlighted, that 1 meter equals 1,000 millimeters, that 1 meter equals 100 centimeters. I don't think that's on the review sheet. And 1 kilometer actually equals 1,000 millimeters. Measure what is the distance in centimeters, point A to point B on the spider. Some students measure A to B. Some people notice that it says on the spider. Some people measure from the edge of the ruler. The numbering doesn't start to almost 3/4 of a centimeter in. I'm going to put this right here and right there, and I'm going to call that 6.5 centimeters, because clearly it's more than 6 and not 7. How many of these spiders would fit side by side in the length of 1 meter? Well, I'm just going to kind of start thinking of some things here. Hopefully that you're in math. 6.5, if we had 10 of those, that would be, you would just have to move the decimal, so that would be 65 centimeters. So it's going to be more than 10. And if I did 20, that would be double that, and that would be over. So I'm going to guess maybe about, let's see, that's about 40. So let's go about 15 of these. And I'm just taking a guess. I didn't finish the math. So a blank is a place used for comparison. So I need a reference point. Why is it important to know if your reference point is moving? You won't know you're moving. You are moving. Unless, and let's just shorten this, your point is, and I want to use that big word, stationary. Okay, so I highlighted the information that's in the book. If you didn't read it, it's going to take you a little bit longer to do the review sheet. And I strongly suggest that you look at the Google slideshow and write down and copy your notes. It'll make it easier for you to do the worksheet on Wednesday. Cohorts A and B were given hard copies, and remote, I will attach it to today's lesson. Tomorrow's lesson, actually, because I'm here on Monday. Thank you and have a good night.